Welcome students. In this video we shall see problems on stress and strain. A steel pipe is used to support a load of 150 kN. Pipes having outside diameter of 101.6 mm are available in different thicknesses of 3 mm, 3.5 mm, 3.65 mm and 3.85 mm. Assuming a factor of safety of 1.8, choose the most economical thicknesses. Welcome students. In this lecture we shall see problems on stress and strain. A steel pipe is used to support a load of 150 kN. So this is your force P. Pipes having outside diameter of 101.6 mm are available in different thicknesses of 3 mm, 3.5 mm, 3.65 mm and 3.85 mm. Assuming a factor of safety of 1.8, choose the most economical thickness. Yield stress is equal to 250 Newton per mm square. The outside diameter is given. So four thicknesses are given. Out of this you have to choose the economical one. So the given force is 150 kilonewton, outside diameter is 101.6 mm. Four thicknesses are given: 3.5 mm, 3.65 mm and 3.85 mm. You have to choose any one. The factor of safety is 1.8 and the yield stress is 250 Newton per mm square. We have to find the economical thickness. We know that factor of safety is equal to yield stress by permissible stress. The yield stress is given and factor of safety is given. So from this equation you find what is the permissible stress. So permissible stress is equal to yield stress divided by factor of safety, that is 250 divided by 180. It will be giving you 138.9 Newton per mm square. So this unit you have to note, because yield stress is in Newton per mm square. So your final value, that is the permissible stress, is in Newton per mm square. We know that stress is equal to force by area. So the permissible stress is equal to force P divided by area. The force is 150 kilonewton or 150 into 10 power 3 Newton. The permissible stress is in Newton per mm square. So your area will be in mm square. So area is equal to 150 into 10 power 3 divided by permissible stress. So you know what is the force and what is the permissible stress. Divide both these values, you will be getting the area in mm square. When you see from the top, you can have an image like this. So outside diameter capital D and inside diameter small d. The area of the circle enclosed by this diameter d is pi by 4 small d square. If you want to find the area of the hatched portion, so that will be equal to pi by 4 capital D square minus pi by 4 small d square, because this is the area which is going to take the load. So area A is equal to pi by 4 capital D square minus small d square. This is equal to 1080. In this, you know what is capital D. So find what is small d. So small d, you substitute all the value for getting the small d, you substitute all the remaining values and find what is small d. So d square minus small d square is equal to 1080 into 4 divided by pi. It will be giving you 1375.8 mm square. So capital D is 101.6 and small d you have to find. So substitute all these values, you will be getting 94.59 mm. So in this figure, this is thickness and this is diameter and this is thickness, and the total From here to here is the outer diameter. So I can write capital diameter, sorry, outside diameter, that is capital D is equal to inside diameter plus 2 times the thickness. From this equation, you can get what is thickness. Thickness is equal to capital D minus small d by 2. So you know what is outside diameter and inside diameter. You subtract and divide by 2, you'll be getting the thickness. So thickness is 3.505 mm. This thickness, you have to choose a thickness which is greater than this value. So the available options are 3, 3.5, 3.65 mm and 3.85 mm. The next available value is 3.65. So this is your economical thickness.